Right, welcome back, viewers. Here we'll be looking at another conic section, which is called the ellipses. In our last video, we talked about parabola. So now we have to define, if you remember the geometric definition of a parabola, we say the distance from any point to the focus is the same thing as the distance from that point to the directrix. That distance is always the same. But let's see what we have for ellipse. So we said ellipse is a set of points in the plane where the sum of the distance from the two fixed points is a positive constant. So we will discuss that later. But let's define these, the important things we have for an ellipse. So we said the graph of an ellipse has two sets of symmetry. Unlike in the case of parabola, we have only one axis of symmetry, but in the case of ellipse, we have two sets of symmetry. The longer one is called the major axis. So the longer one is called the major axis, and the shorter one is called the conjugate axis. And both of these axes, they are very important. Both of them, they divide the ellipse into two equal halves. Okay, so just like this now, you see the longer one is going to be the x-axis, while the shorter one is the y-axis. So now that is about the axis of symmetry. We have two axes of symmetry. The longer one is called the major. The minor one is called the smallest one is called the minor axis. Then there is what we call the center of an ellipse. The center of an ellipse is usually the midpoint of the major axis. So once you've identified the major axis, which is the longest axis, then you take the midpoint. So for example, now this is the midpoint of the major axis. So the midpoint will be somewhere here. This is the midpoint of the major axis because the major axis is the x-axis. So that becomes the center. Then the endpoints of the major axis are called the vertices. So the endpoints of the major axis are called the vertices. So if you want to find the vertices, first of all, just have the what? Once you have the major axis, then the endpoints, these are the endpoints. So these are called the vertices. So that is why we have two vertices. And we can now talk about the focus, which is just a little bit away from the from the vertex. So you have two focus as well. So let's discuss the two types of ellipse we have. There are two types of ellipse. We have the horizontal ellipse and the vertical ellipse. Now, if you look at this table, we have ellipse which is centered at where? At origin. So the center is at origin. So for example, for a horizontal ellipse, we said the major axis is the what? Is the x-axis. It means that the x-axis is the what? Is the longest. Why in the case of the vertical ellipse, for vertical ellipse, what is the longest? The y-axis is the longest, so it is the major. That is the major axis. All right. So once you have this one, once we have our major axis, this is our major axis in this case, you see the endpoints. These are called the vertex, and that is represented by A0. Remember, the center here is 0, 0 for this particular case. All right. And then the conjugate axis will be the y-axis. So, and that is where you have 0, b. X is 0, minus b, 0, and b. Then you can have the foci, which is the C here. So we have two focal points. So we have one C and we have another one here. And they are given by this point, minus C0 and C0. So how do you find C? Already, you know, A and B will be given from the standard equation, which is this one. But here you see the condition that A is always greater than B. And so here, this is when you are dealing with horizontal ellipse. But when you are dealing with vertical ellipse, look at what changes. This is y square, right? So you have y square, the bigger one, or the longer length, or let's say the major axis, is the y-axis. That is why you see that A is associated with y. Remember, A is always associated with the major axis, which is the longest axis. All right. And now, how do you find C? That is clear from this diagram. You can see this distance is B. Pythagoras theorem here, you will get what? You will get A squared is equals to B squared plus what? C squared. And you can make C squared the subject of the formula, and you will arrive at getting the C here, which is the same here. Okay. So once you have the C, then you can find your focus. So your focus, or it will just be plus minus. Now remember one thing, the focus is always also on the line of the major axis. So the focus is on the line of the major axis. Even the vertices, they are also on the line of the major axis. Now here we have this important, the length of the major axis is called 2a. The length of the minor axis is twice b. The distance, and that is what we define, remember we define an ellipse, that every set in a plane, in an ellipse, the distance from that point to the foci, the first focus, plus the distance from that point to the second focus is a positive constant. And what is that constant? It's just twice, just 2a, which is the length of the major axis. So as you can see here, this is what we're saying. Take, for example, if you take any point here, the distance from here to here is a. The distance from that same point to the second foci, this is also going to be a. So this is a, this is a. By the time you add it, it's just going to be, so the distance from, when you are dealing with an ellipse, the distance from any point to the first focus plus the distance from that same point to the second focus is just going to be twice a, right? So this is very important. Remember, for parabola, we say the distance from any point to the focus plus what? The distance from any point to the directrix, right? And we say the distance are always the same, right? So the distance are always the same. This is in the case of a parabola. But in the case of an ellipse, the distance is always twice a. But in the case of ellipse, remember, we don't have directrix. So don't mix it up. Now, another thing important is the eccentricity. Eccentricity is given by C, by the ratio C over A, which is always between 0 and 1 for ellipse. And if your eccentricity is approximately equals to 0, it means that your ellipse will almost look like a circle. For example, if you have eccentricity to be 0.001, this is a very small number, very close to 0. So it means your ellipse will look almost like a what? Like a circle. Yeah. So it means that if eccentricity is 0, it will look perfectly like a what? A circle. Now, if eccentricity is closer to 1, then it's going to be either long or thin, depending on whether you are dealing with a vertical or a what? Or a horizontal. If you are dealing with horizontal, it becomes something like this. If you are dealing with vertical, it becomes so thin. This is these two cases when your eccentricity is very close to 1. Okay. And I could remember one of my students asked what if eccentricity becomes 1? If eccentricity becomes 1, then it means that it will just become like a line, right? Here, if eccentricity becomes 0, it means it will become a circle. All right, so let's take examples. Here, we're asked to graph each ellipse, and we're to find the coordinate. So let's start with the first one. So the first one is A here. This is x squared over 4 plus 9y squared over 16 is equals to 1. So the first thing you observe is that all of this, the center is what? Is 0, 0, right? Because there is no shift. Now, since there is no shift, what can you do? You have to write it in standard form first. This is x squared over, this you can write as 2 squared plus, but this you need to get rid of this 9. So this is going to be y squared 16 over 9 is equals to 1. So you are dividing the numerator and the denominator. You're dividing by 9 just to get rid of that, right? Okay, now this is going to be x squared over 2 squared plus, this is going to be y squared over, this you can write as 4 over 3 all squared equals to 1. Okay. Okay, so now you can see that what is A? You can see that a squared is equals to 4. So you can see A is just 2 and B is what? Is 4 over 3. So which one is bigger? You can see A is bigger. So and A is associated with what? With X. So since A, the bigger length is associated with X, it means that this is going to be what? This is going to be horizontal ellipse. Why is it horizontal? Because the bigger length is associated with what? With X. Okay. Now, since it's associated with X, we can try to get some parameters and try to sketch. So first of all, you see that what will be the center? The center, we know it's 0, 0. You know, so you have to take note of these things. In the case of parabola, the most important thing is what? The vertex, knowing the vertex first. But here, you need to know the center. It's very important. Now, once you know the center, so let me just, I can be graphing along the same time. So let's be doing the graphing here. So let's say we know the center. So the center is 0, 0. And we know our A. What is A? A is already 2. So we know the endpoints, which is the vertices. So here is going to be minus 2, 0, and what? 2, 0. So this will be our vertices, right? And then the other endpoint will be our B, the one associated, which is the the minor axis. So this is going to be 0, 4 over 3, and what? And 0 minus 4 over 3. So we already have. Then we can find our C, right? What is C? C is just going to be the root of what? A squared, right? Minus B squared. So this is root of A squared minus B squared. And this is going to be 4 minus what? 16 over 9. And everything is going to be root of what? 20 over 3. So this is like 2 root 5 over 3. So this is C. C is just 2 root 5 over 3. Let me write it here. This is just 2 root 5 over 3. Now, so that is our C. So let's try to put our C here. Remember, our C will always also be on the line on the major axis. So our C is going to be somewhere here. And the first one is 2 root what? 2 root 5 over 3, 0. And the second one is what? The negative. So let me call this one vertex 1. This is vertex 2. You can call this your F1 and your what? F2. And then we're almost done. So let's just write these things out, so just to have them here. So the vertices is what we know by formula is plus minus a0, which is just what we have there, minus 2, 0, and what? And 2, 0. Okay. Then we have our foci, which is going to be plus minus c0, and this is just going to be plus minus what these two values here, so which is minus 2 root 5 over 3, 0, and then 2 root 5 over 3, 0. Then we can talk about the endpoint of the minor, minor axis, which is just this b here, which is supposed to be 0 plus minus b, right? And this is just going to give us 0, 4 over 3, and 0 minus 4 over 3. So now, do we want to find what and what? We're asked to find the domain and the range, okay? But before we go to the domain and the range, let's find what is the eccentricity. Remember, the eccentricity gives us an idea. So E, eccentricity, E is C over A, which is 2 root 5 over 3 divided by 2. And this is just root 5 over 3. So eccentricity is root 5 over 3. And you can see this number here, it's going to be approximately maybe closer to 0, maybe 0.6. Okay, let's see. This one, we know this is approximately, let's say 2 point something, right? Because the square root of 5 is what? The square root of 4 is 2, and the square root of 9 is what? Is 3. So it's going to be between 2 and 3, right? So this is approximately 0 maybe 6 something, yeah. So this is more closer to 1 than it's closer to 0, right? Or let's say 0. Let's say approximately 0.6 something, or 0.7. Now, good. So what can we get from here once again? So from here, we try to know how. Okay, so this would tell us how wide or how thin our ellipse can be. But here to be more specific, this is going to be actually bigger. This is going to be around 0.7, maybe 0. Yeah, around 0.7 something. Yeah. So it means it is closer to 1, right? It's closer to 1 than it's closer to 0. So what it simply means is that what? Our ellipse is not going to look like a circle, definitely. So we can have just something like this. You just need to connect this point. Okay. All right. So now let's find the domain. Domain is simply the values of x, which is going to be from -2 to 2. And then the range is going to be the value of y, which is going to be from 4 over 3 minus 4 over 3 to 4 over 3. And we're done for the first. That's the A. So let's see the B question. Now for B, what is the function? Let's see, is 25x squared plus 16y squared. So we have 25x squared plus 16y squared. It's equals to 40. Now you have to take this to standard form. Now what will it be? We can divide both sides. This is 400. Can divide both sides by 400. So we will have x squared divided by 400. Y squared over 400 is just equals to 1. And then this will become x squared over 16 plus y squared over 25 equals to 1. So here we divide the numerator and denominator by 25. And here also we divide the numerator and the denominator by 16. So we have this one. Okay. Now, what can we do? This is the x squared. This is going to be a vertical what? This is a vertical ellipse. Why is it vertical? Because here you're going to take a. Okay, let's rewrite it. Because this, we can write this as x squared over 4 squared plus y squared over what? 5 squared equals to 1. So here now you can see your a is going to be 5 because you have to take the bigger one. So your b is going to be 4. So since your a is associated with y, it means you are dealing with a vertical ellipse, right? And then we can find what is c. So what is c? C is going to be the square root of what? A squared minus b squared. And this is just going to be the square root of 25 minus 16. Everything will be 3, right? And I think we're good to go. We have everything now. And now to sketch, how do you sketch? The same procedure. Here we will have this. Remember, our center is still 0, 0. But now our major axis is the y-axis. So if the major axis is the y-axis, then and what is it? It's going to be 5, no, 0, 5, and what? And 0 minus 5. Okay. Then we can have here to be the other one, which is the minor. It's going to be 4. So this is minus 4, 0, and 4, 0. Then this, so that these are the vertices. Then our C, so this is vertex. We can call it vertex 1, vertex 2, or vertex 2, vertex 1. It's not a problem. So no, sorry. This is not our vertex. This will be our vertex V1 and V2 because the vertex is always on which axis? Is on the major axis. Also the focus. So this will be our focus here, and one of our focus will be here. So remember C is this, so our focus now will be 0, 3, and what's 0 minus 3. So this is our F1, and this is our F2. All right, so let's write this data out before we try to, before we plot it. So what am I saying? I'm saying that the center is just 0, 0, and the vertices in this case is going to be 0 plus minus a. And what does that mean? This is 0 plus minus 5, right? So it means you have 2. And then as well, the foci is also going to be 0 plus minus c, which is going to be 0 plus minus 3. Okay. And then you can talk about what else? Endpoints of the minor axis. And point of the minor axis. Okay. Yes. So what is this one? This is just going to be the minor axis now is going to be on the x-axis. So it will be plus minus b and 0. And that is going to be plus minus 4 and what? And 0. Then we can find the eccentricity. So what is eccentricity? So let's say E is equals to what? C over A, which is 3 over, what is A? This is 3 over 5, right? Yeah, so 3 over 5. And this is going to be around 0.6, right? Let's say 0.6. So you see, this is also closer to 1 than it is closer to 0. And we can, okay, let's finish this one. So to graph this, you will see that you just need to combine this. And no, something is missing. No, not this. You have to go from this to this, not a straight line, but okay. Like this, then also like this. All right, just roughly something like this, yes. So here we can find what? We can write out the domain and the range as well. So what is the domain? Domain is just the x values, so it should be minus 4 to 4. And the range is the y value, which will be minus 5 to 5. Okay. So we have one more to go. That is the C part. So what is the C? Let's look at the C here. The C is talking about what? It's talking about half, I think it's a half ellipse, right? It's half ellipse, which is y over 3. It's equals to minus root of 1 minus x squared over 4. So what do we do here? You just square both sides. This you can write as y over 3 squared. It's equals to this also, I'm squaring both sides. So this will give us y squared over 9 equals to what? 1 minus x squared over 4. So if we write this, we will have y squared over 9 plus x squared over 4 is equals to 1, which we can write as y squared over 3 squared plus x squared over 2 squared is equals to 1. Now you can see here what is bigger. What is bigger is still the A. So you take A is equals to 3 and B is equals to 2. Now this is still a vertical ellipse. Now, why is it vertical? Because the A is associated with the y-axis. All right, but it's not going to be a full, it's going to be half, right? Okay. It's going to be half, but we will talk about that later. Because remember, this is not what we're given. Because we squared both sides. So it means we're only expected to have the half of it. So let's try to graph this and see what it looks like. But we know that this graph, the major axis is going to be on the y-axis. So it means I'm going to have, this is going to be my vertices. So this is going to be 0, minus 3. And here, up here, I'm supposed to have 0 and what? 3. And then for the minor axis, you're going to have something here. Let's say minus 2, 0. Let me expand it a little bit. So minus 2, 0. And then what? 2, 0. Then what is our focus? So this one, let's call it vertex V1, V2. So our F will also be somewhere here, so that we can find what is C from here. So C is what? The root of what? 9 minus 4, which is just the root of 5. So it means we're going to have it also here, 0 root 5. And what? Here, 0 minus root of 5. So this point is our F1 and F2. Okay, and we're done. So just remember, we're supposed to have something like this, a full ellipse. This one, something like this. Okay. And also we're supposed to have, this would be the full one, complete one. Okay. But in this case, you don't need to complete it because you are dealing with half. And you just take, because we have a minus here. So you take the part that is what? That is below. So it means we have to delete which part? So we have to delete this part, this part. So we have only this half part. So if here we're positive, we would have taken the what? The upper part. So this is, we can say this is half vertical ellipse. Okay. And then we can still find everything we want. We can find our domain. But now you see the domain is still going to be minus 2 to 2. But the range now will change. Our range is just going to be from minus 3 to 0 because it's not complete. So you cannot take minus 3 to 3. All right. Here, let me just write every other thing here just to, the center is still what? 0, 0. The vertices remains the same. The vertices is on the y-axis. So this is 0 plus minus a. And this is what? 0 plus minus what? Plus minus 3. Then we have the foci is still going to be 0 plus minus c, which is 0 plus minus root of what? Root of 5. And you can see the endpoint of the minor axis. The endpoint of the minor axis is still going to be 0 plus minus c, not 0 now, but it's going to be on the x-axis. So this is plus minus b0, and this is plus minus 2, 0. All right, example 2. Example 2 is saying that what you have, find the standard form of the equation of an ellipse that has a minor axis of length. So length of, what is the length of minor axis? Length of minor axis is what? Is twice b, right? So you are given the length of the minus axis is 6. So you have 6 is equals to 2b. And this means that b is equals to what? B is equals to 3. And you have the focus already. So it means what is C? So C is what? So focus 0 this and what's 0, 4. This implies that what C is equals to 4. Okay. And then, and also one thing is that since the C is on the what? On the y-axis, it means that you are dealing with what? You are dealing with a vertical ellipse, right? So this also implies that we are dealing with vertical ellipse. So this vertical ellipse. Yes, because we know the focus, this is going to be 0 minus c. and this is 0 and C. So since we're dealing with a vertical ellipse, we know what the formula should be. The formula of a vertical ellipse, it means that the biggest number should be associated with what? With y, right? So, but let's see, we can find what is A first. As you can see, we know B, we have C. So these two, what is this implies that A, remember we have C squared is what is A squared minus B squared. So A squared is what? C squared plus B squared. And this is simply that A is going to be the root of this one, C squared plus B squared. And which is the root of, what is C squared? This is 16 plus B squared, which is 9. So A is going to be 5, right? So if A is 5, it means we have x squared over what? Plus y squared over something is equals to 1. So since A is bigger, so it means here will be 5 squared. And here will be what? 3 squared. So this is our equation because we're dealing with vertical ellipse. So A is 5, B is what? 3. And I think we're done. Okay, now one more. So this one is example 3. What is example 3? Now this one, you can rewrite it. You can write this one. You can write it as y squared over what? Over 25 plus what? X squared over what? 9 equals to 1. They're all the same. So for this one now, example 3 says we want to find the standard ellipse which major axis is on the what? The major axis is on the x-axis with length this. So length of major axis. How do you find length of major axis? It's just twice A. So the length is 12. So 12 is equals to twice A. So A is equals to what? 6. But since we know that the major axis is on the x-axis, it means you are dealing with what? We're dealing with a horizontal, right? Ellipse, right? So we can write it, major axis on x-axis. It implies that you are dealing with a horizontal ellipse. So it means that the bigger number must be associated with x, right? So it means we will just have x squared. So it's going to be x squared over a squared plus what? Y squared over b squared is equals to 1. And already we have a from here. So you'll have x squared over a is what? 36 plus y squared over what? B squared is equals to 1. Right? So what else can we do? Let's move here. Now we're going to use the points here. Which point? We're going to use this point to find B. So the point is what's 2 minus 3, right? Point is on the ellipse. So since this point is on the ellipse, you take this to be your x, you take this to be your y. So remember the ellipse is this one. So what is x? X is, so this is going to be 4 over 36 plus, what is y? So this will be 9 over b squared is equals to 1. And this simply means that what? This means that 9 over b squared is going to be 1 minus 4 over 36. Okay. And this is going to be 9 over b squared. It's equals to what? So this is going to be 32 over 36. Correct. Yeah, because you have 36 minus this one. Yeah. So here, we can always simplify it by 4. So 4 here. So we'll have 9 over b squared. This one is going to be the same as what? 8 over 9. You can simplify this by 9. So this becomes 8 over 9. So we have 9 over b squared is equals to 8 over 9. Okay. So it means that what does that mean? It means that your b squared is just what? It's just 81 over 9. 81, yeah. No, 81 over 8. This will be our b squared. So it means we can go back and finish. So what will be our equation? Remember, our equation is x squared over what? Over 36. So it means we will have x squared over 36 plus y squared over b squared is 81 over 8. Everything over 8 equals to 1. So let's get more space here. Okay, let's just move here. So we will have x squared over 36 plus y squared over 81 over 8 equals to 1. And that is it. And you can take 8 up so that you just have 8y. Yeah, so this is the equation of the ellipse. All right, so I think that is enough. In our next video, we'll look at ellipse with a shifted center. It means the center is not at origin. Thank you for watching.